In this video, the differences between additive and subtractive manufacturing processes will be visualized using common materials at home. An analogy is created using two loaves of bread, one of which is sliced, and some sticky cheese. Subtractive manufacturing processes are about taking a big chunk of material and reducing it at the locations where the material is not required to form the geometry that is wanted. As you can imagine, the removed material is wasted. Furthermore, most of the cuts must be done in steps because they are hard to do in a single maneuver. In this video, an analogy for subtractive manufacturing processes is done by taking a whole piece of bread and cutting it using a knife. On the other hand, additive manufacturing processes are about joining particles, pieces, or sheets of material in layers. The material can be in liquid, solid, or powder form, and it is melted, sintered, or cured into layers. The analogy in this part was inspired by the laminated object manufacturing process, where the material is in solid and sheet form, and these sheets are stacked on top of each other using adhesives after getting cut according to the layer. The analogy is that bread slices are the sheets and the cheese is the adhesive. Note that the second analogy also requires some cutting. However, it is simple to do and it is an effective way of showing how layers come together in other additive methods. What you are seeing right now is the constant cross-section of the part I randomly came up with. Its width is 50 in millimeters, like every measurement here. Bread slices are 20 millimeters thick, so we need to use 5 slices. As you can see, I draw a line from the middle points to calculate the slice length. The top part only covers half a slice, so the distance here is divided into 2. So this is the result. I calculated this by hand, but of course, normally a computer will calculate this and generate a G-code rather than pure measurements. I also calculated the distance between the layers. As you can see, they are in blue, while the lengths are in orange. And this is enough to form the part. We first start with cutting. I'm getting a knife. And we are going to cut 100 millimeters long and 90 millimeters high. So we are going to cut 100 millimeters and 90 millimeters. Of course, cutting can't be done in a single step. It needs to be, and as the before, it can't be done in a single maneuver. As we cut the top fibers, we go down to the bottom, and now I'm trying to cut the bottom fiber. Now we are doing the second cut, and that will be 9 centimeters. Now, this piece contains the part we are going to make. It's 90 millimeters that way, it's 100 millimeters this way, so it stays like this. This is the piece. I'm marking like 35 here, so this is 35, right? Then I'll mark 40 this way. It is done. Same procedure will be applied this side. I'm going to cut this part away. 35 along this. $10 millimeters. So they connect. We are going to cut 35 in this direction, which is along this line.
So it must be something like this. And that is that cut. That was this. Along this. So connect these 2 points. Then it's not visible, but these 2 points needs to be cut. This part is this. This is 65. Connect at 35. Like this. The last cut is along this. And with that we are done. And this was this. And that concludes. Now these are the remaining parts. These are the scraps, you can say. I'm going to cut it here. It doesn't really matter where. It needs to be cut, unfortunately. This laminated object manufacturing method actually consists of cutting the sheet first. And that is what we are doing right now. Let me have a look at that. And that's here. Now we're going to cut right here. And this is it. That's like I need to cut 48.75. Okay, we get rid of that. Okay, this part goes here. So 45, 48, 49 approximately here. Put it there. Okay. I think it's probably like that. It'll be like this. These are the remains from all the cutting done. This is the laminated object. This is the cut object. These are what's the crumbs from the cutting.